This is part 2 of the piping workshop number 3. The other video was running a little long, so we had to split it into 2. So what I've done is I've drawn my second control volume here, and from that control volume I'm going to use to calculate out net positive suction head available. So let's skip ahead here to a clean sheet, and let's draw our energy equation on that new, smaller control volume that I just put together. Still coming in at 0.1. But now it's coming into the suction side of the pump. So instead of writing out here, we'll just call that the suction side of the pump. And that's going to equal H of the turbine. Oops, sorry, not equal. It's going to be plus H of the turbine minus H of the pump plus the total head loss through there. No turbine and pump, so those guys will cancel out. There is zero height difference between the two. Now I do need to get NPSH out of that, so I'm going to add and subtract the vapor pressure head. And once I do that, I will take that term and I will turn that into NPSH available. So what we have is P1 over gamma plus V2 squared. V1 squared over 2G is going to be equal to our net positive suction head available plus H total plus PV over gamma. So if I rearrange this guy for net positive suction head available is going to be the difference in the regular pressure and the vapor pressure. Now this time we're going to have to use absolute pressure because the vapor pressure is an absolute. Minus V squared over 2G minus H total. Actually, quickly looking back on that equation, we're plus V squared over 2G. Okay, so we can start plugging everything in. Pressure at 0.1 is going to be 14.7 psi plus the 5 psi gauge to get that into absolute pressure minus 1.64 psi is our vapor pressure. And then I'm going to convert that by going 12 inches over 1 foot squared. And then I will divide that by my 48 pounds per foot cubed. I'm going to add to that, and I'm going to bring it over the next line because we're running out of room. 4.6 feet per second squared divided by 2G, 2 times 32.2 feet per second squared. Now we're going to subtract from that the total head loss. We only have major losses here because there are no minor losses in that first part of the problem. Take all the data that we already calculated. 0.024 is my Darcy friction factor. 200 feet is my pipe length divided by 2-inch diameter divided by 4.6 feet per second squared divided by 2 times 32.2 feet per second squared. Look at things, units are all fine. Once I bash all that into my calculator, I'm going to get a net positive suction head available of 44.68 feet. The pump requires 40 feet of net positive suction head. We have more available head than what is required, therefore no cavitation. So this pump is fine for our application.